Hello, everybody. Welcome to today's webinar, Fix What You Got, Cylinder Sleeve Liner Solutions. I am Amanda Harmoning. I'm an admin assistant here with AERA, and I will be moderating today's event with my colleague, Rob Monroe.
Hey everybody, yeah, Rob Monroe here. I look after membership and technical development with AERA. And we're going to do things a little bit different today, probably a little bit different than what you're used to if you've been to our webinars before. Dave's going to be doing a live presentation, and it's going to be right from LA Sleeve headquarters down in LA. So there may be a few times where you may see the feed could be a bit choppy, or there could be some background noise from time to time. He's got some equipment running. I mean, this is literally a hands-on, right in the shop kind of webinar today. So anything that pops up as far as the technical issues, I mean, this is a bit of out of our control. We're just trying to give you that live in-person demo today. So really looking forward to this one there. Another thing that we got on the go, Steve Fox and Chuck Lynch are techs here at AERA, and they've got the Engine Professional podcast that they do. And if you go out to our website, the AERA website, you'll see there's a tab there for podcasts. This is just another, more technical information. We're trying to get as much information to you as we can. And the podcast, I know they just finished and wrapped up episode 12, and that was anything related to torque plates and torque plate honing. So check that out as well. The podcast, lots of really good information, and they're about an hour long and great for a drive home or a Friday night just before the weekend starts and have a listen there. Engine Professional Magazine, we just released our fourth edition, our Q4 edition. So that should be hitting mailboxes now. You should have a copy of that. If you'd like to read it just digitally, you can go out to engineprofessional.com right on our website, and you can also check that out. And for those of you that are on today that are not getting Engine Professional and you'd like to get a copy, we do mail that out. So if you just let Amanda know in the questions box, she will get some information from you, your address and that kind of stuff, and she can get that over to you, and we'll make sure you start getting and receiving Engine Professional. So do check that out as well. All right, well, enough out of me. I'm going to bring on Dave Metchkoff, and Dave is from LA Sleeve, and he's a fourth generation business out there that started back in 1945. And if you got any questions for Dave, by all means, put them in that questions box at the end, and just up in your control panel, we'll get the things over to Dave and get those questions answered. So Dave, I'm going to put things over to you. So how are things going down there this morning?
Things look fantastic here in Southern California. I'm glad to thank AERA for this opportunity to show a little bit about our company. And I want to thank you, the viewers, for stopping in. I'd like to welcome you into our company. As Rob said, I'm a third generation. We're a family business. LA Sleeve was started in 1945 by Nicholas W. Metchkoff. We're just into our 75th year anniversary as a family business. Still doing it here in Southern California. Grandfather started the company in Los Angeles, and we moved over into Santa Fe Springs, California, which is in LA County. And we're still doing it here today. Fully manufacturing here in the city of Santa Fe Springs, having all of our material made here in the United States as well. As I kind of present this tour to you folks, first wanted to give you an idea on how we manufacture the sleeves, how it starts, how they're finished, and then after that, give you an idea on why you should fix what you got. We're standing outside the building. The material that we have made comes into our building, and we actually have it sitting out in the yard here, as you see behind me. This particular material is a triple spun cast iron, as you can see. We call it weather treated. If you studied iron blocks over the years, you guys would realize that iron has a living molecule in it. And what we do is when the material comes in, although heat treating is much better than it was in days in the past, we still like to have it weather treated. You can see rust kind of builds up on the surface. This is how a sleeve is started. Comes in as a raw casting. We have it sitting out in the yard for a few weeks, let it get weather treated, and then we take it to the building, start machining it from there. The tour I'd like to give you guys would be no different than when a visitor comes in, wants to, talk to us, and we'll give anybody a walkthrough, let them show what we do as a business. So come on in, I want to show you what we got going on. In this room, there's our manufacturing. And we have a convergence of old school machinery and new school technology. Let me give you a perfect example of this right now. So I'm standing in between two machines. We have on this side Cincinnati centerless grinders. These were built in the early 60s, still working to this day as good as they ever were. I'm going to bring you over and take a look. When a sleeve is machined, it's got a rough surface on the outer diameter. From that, you take it, put it into this machine right here. And I like to have you guys take a look at these grinding wheels. Old school technology, but these wheels are actually infused with diamond. And it allows us to grind the outside diameter perfectly round, perfectly straight, so that the product that you guys see and that you guys use is the same from part to part. That's how we finish the sleeves. Old school technology. Now, as a convergence of new school, I'm going to show you some CNC machinery that we use to produce our sleeves. Here we have a 4-axis CNC milling center. I can take you into the machine right here. What you're seeing here is we take our sleeves. This is a 2-stroke sleeve, and this machine will cut all the portal holes into the sleeves in exacting tolerances, heights, widths, allowing the installer to put in a 2-stroke sleeve with very little or minimal port grinding. These are brand new machines. We try to update our machines about every decade if we can. We brought these in this year as a necessity, frankly, trying to speed up our production and produce a better quality part. Same thing on this side. 2 modern day machines. As you can see here, what we do is we take the blank sleeve, cut portal holes into it. This is what would be used in a Mercury D6 outboard block. Follow me along. All of our machines that we use these days are CNC operated, as I just said. Down here, I'm going to show you the lathe that we use to produce the blanks. Come on with me. As you can see here, typical lathe, CNC operated. Rough casting goes into the chuck. Machine comes in, starts machining the outside diameter, machining the inside diameter, and it'll part it off. As you can see here, it's about to cut the inside diameter of the sleeve. We use basic carbide cutting tools, not unlike the boring cutting tools you guys use in your machine. Again, all modern technology, carbide infused tips. That's how we produce. Back in 1945, grandfather started the company. We used manual overlay, current lathe, and in 1984, we stopped at a machine show in Los Angeles, California. Grandfather did not believe machines. Was somewhat afraid at the cost, somewhat afraid at the investment in machinery, and a rep came into our company. We provided him the sleeve and showed him what we do and how we make it out of an engine lathe and a current lathe. So he had set up a machine at the Los Angeles Machine Show, and what in that time took us 4 to 5 minutes to produce a part only took 2 minutes. When grandfather saw that happen, he said, "Buy that machine." We did. Since then, we've been slowly putting CNC machinery, and starting in roughly 1992, we're fully CNC operated, with the exception of centerless grinders and these engine lathes I'm about to show you now. Here's an old school engine lathe. I'm sure many of you guys still have these in your shops. It does everything from facing cylinder heads. We can machine sleeves, machine castings, machine heads, all done on an old school engine lathe. Still to this day, works almost every day we use. I'd also like to show you a machine that's very unique. I know we've talked to a few reps with Sun Homes, and this is a machine, although they've worked with Sun and haven't seen something that was uniquely built for us and just a few other companies in the United States. Let me show you this old school but new technology CK10. This is a dual-headed CK10. From what we understand, only 7 of these were built by Sun back in the late 90s. They built this machine for 2 reasons. Number one, they built it for high production honing on engine blocks for the aftermarket engine companies. And they built it for someone like us, which we can produce sleeves that are finished honed on the inner diameter. Similar to this is an Alfa Romeo sleeve that has to be finished honed. We're able to produce the sleeves in high volume. Set one sleeve up in one head. The machine operator could start it. It's an NC operated Sun. Start that hole, and then move over to the next head. Set up the sleeve, have that going, and go back and forth. This is one way we're able to speed up production for high volume sleeves, and it was just an amazing investment for us. We've been using it for over 25 years. Still to this day, operating quite well. The machine not only finished hones our sleeves for us, but we'll take a Subaru block like you see here, put on your basic torque plate, which I'm sure many of you are familiar with, torque plate it, put it in the machine, we'll go ahead and hone it, finish it up, just like anybody else would. What's nice about this machine as well is if we are doing a Subaru, we could do 2 blocks at the same time, or we could even hone a block and hone a sleeve at the same time. It's really good for a company like us. High production, can move things along, and with as busy as we've been lately, it's really a nice machine to have. Let me bring you along through the shop. Currently, we have roughly, we've got 4 manual machines, engine lathes, general grinders, and we have 14 machines producing lathes and mills, producing sleeves in various sizes. We go down as small as 3/4 of an inch, and we go as large as 8 1/4 inch bore. Frankly, we can go to 10 inches if we have to, but it's very rare that a sleeve would be needed in that bore size. As the sleeves are produced, it goes through its process with the raw material, machining in the lathes, centerless grinder, and when we're done, we quality control everything we do. I'd like to show you just a quick tour of our quality control department, give you an idea of what we do in there. Come on with me. Welcome into our quality control room. What we have here is a air controlled, always at 72 degrees, CMM measuring devices. We'll measure sleeves. We'll measure linear dimensions from engine blocks. We can measure mains to see if there's any loss of tolerance on mains. We use this machine, and I'm going to turning it around here. We have this machine as well. We'll take this machine. We measure bearing houses. Let me show you. We'll take these Honda transmissions and we sleeve these, which I'll show you a little bit later. We'll take these bearing transitions. We'll come in and we'll check the tolerance loss in each of the bearing houses. And knowing what kind of loss there is, we have specific sleeve thicknesses that we use to repair these transmissions. All of the sleeves that we produce and the engine blocks that we sleeve will be quality controlled, just so that we know, we log it in and know that the product that we're sending out the door has been checked, chronicled, and if anything gets out the door, we know what kind of tolerances that we produce, and we could discuss it with our customers from there. I'll take you further out. There's another CNC milling center. We call it a cell in our company. And as you can see on the ground here, we have various sleeves, various different applications. This particular sleeve we use in a D16 Honda. Might be interesting to some of you folks. Another interesting sleeve we're producing right now. This is for a Rolls-Royce Phantom 3. Limited model, as some of you guys may or may not know. And the sleeves, of course, are unobtainium. So we custom build sleeves for various engine builders throughout the United States. Especially on these vintage models, obviously, you know, the manufacturer's not going to produce them any longer. So folks like yourselves send us sample sleeves when rebuilding a old school Ferrari, Maserati, Rolls-Royce Phantom 3. And some of these sleeves have to be machined at the bottom. This is machined for a crank throw. So we've got a little clearance at the bottom of that sleeve there. Here's another interesting sleeve. You guys might be drag racers or rebuild drag racing blocks. That is a KB sleeve, Keith Black. It's a 4 3/8 bore size, big bore sleeve that we're making. Just producing sleeves for an engine builder in Nevada. And we're still producing sleeves for TFX, Keith Black blocks, old Rodec blocks, whatever the case may be. Again, these are hard to come by these days from Keith Black, so engine builders will reach out to us, have us produce these, and we can do that for you as well. Come on in. Again, here we are producing two-stroke sleeves. This is for a Honda CR500, kind of a thick wall sleeve. A lot of the Honda CR500, which is a motorcycle, the bottoms of the cylinders break off quite often, and we produce a sleeve to repair that area. So again, thank you for coming in. I hope that tour was interesting to you. That's our manufacturing facility. We have two facilities here on the property, two different buildings. Not enough time to show you both buildings, and frankly, it's sort of the same thing. We machine and sleeve two-stroke cylinders on the buildings across the parking lot. But this is where I wanted to end up and discuss the topic today, which you've obviously joined us. This is one of our CNC machining centers as well. This machine can produce sleeves, machine engine blocks, machine heads. It's kind of our go-to machine for many different products that we produce. The reason I wanted to bring you guys into our company today, you may have noticed this throughout the last 18 months. I think if you're watching this, you've been very busy. If you're a machine shop and you're in business, you've been very busy. Before the pandemic started, 2019 going into 2020, things were okay, but you know, not as brisk as we hoped. When the pandemic closed down the country and the rest of the world, a lot of the people here in the United States had a lot of free time. They got on started rebuilding the race cars, rebuilding their motorcycles, ATVs, jet skis, boats, whatever the case may be. And they went out and had some fun because they had some extra time. Terrible time, obviously, but as you probably know, business picked up from that point on. And as the pandemic worsened, manufacturing throughout the world stopped. And as you know, engine blocks are hard to find, heads are hard to find, crankshafts are hard to find, pistons are hard to find, sleeves are hard to find, all hard parts. So the consumer or the engine builder essentially had to fix what they got. That's the reason I wanted to talk to you guys today. We found roughly our business has increased roughly twice as much as it did from 2019 into 2020 and going into 2021 based on the pandemic and based on the fact that parts are being impossible to find. So our business picked up. Everything picked up. Sleeving, from selling sleeves for industrial, selling sleeves for automotive, selling sleeves for power sports. Power sports being motorcycles, ATVs, jet skis, snowmobiles, and outboard blocks. We've seen an incredible influx of demand for fixing of those parts. And I think you guys have as well. And so what I wanted to do is kind of give you an idea and hopefully encourage you to kind of broaden your ideas on how you can make money. Your machine shop should be a profit center. Your machine shop should be a way for you to make money, not on what you're currently doing, but what you can do and what you're capable of doing. If you are willing to step out of the box a little bit and broaden your minds, rather than doing just heads or cranks for automotive or doing blocks for automotive, I think you can make more. I think you can see where you can make more money for yourselves in the power sports industry. So what I want to do is go over a few different high volume items that we've been seeing this year. Kind of give you an idea what maybe you can look for or solidify what you've been seeing as a demand in business, in rebuilding. So I want to bring you in here. What we have here, two different blocks. This is GM Ecotec. This is a Honda K24 block. I'm sure many of you guys are working on V8s. I'm sure many of you guys are working on sport compact motors. The sport compact market has been very strong the last 10 years. Personally, I prefer V8. I like the power. But for the young person, the demographic who are really interested in racing, they can't afford V8 motors, so they have to start with the V4s. These are a couple of different sleeve setups that we offer that I think you should consider. These two being our most popular sleeve demands. Okay, this is what we call an open deck. The block, this is a cutout, as you can see. This is an open deck block right here from the factory. This is all aluminum with a slight cast-in sleeve. What we do is we cut out the aluminum, or we have you, the engine machine shop, cut out the aluminum and produce a sleeve that is what we call an amphibious design. It's a dry press fit down below, wet sleeve on top. That's the amphibious design. This type of sleeve job doesn't require CNC machinery, but CNC does obviously speed things up, but by no means do you need a CNC. This design for this Honda block, this is called a closed deck design. Some will call it an integrated sleeve design. Integrated meaning the top of the sleeve finds itself lightly pressed against the outer deck of the block, as you can see here. When the sleeves are installed, closes the deck off. So although this starts as an open deck design, it goes into a closed deck. And what this is going to do for you is two things. The closed deck is going to give you a little bit better gasket surface, a little bit stronger gasket sealing area. The closed deck also, because there's more girth in the sleeve, allows you to put more boost in the block. And a lot of the young people these days, when they're building race cars, what they want to do is they're either going to run high turbo boost, or they'll even spray with nitrous at the same time, producing enormous amounts of horsepower on these little motors. A motor that's roughly 240 horsepower out of it's an OEM design. These are winning races, drag races, at 1,500 horsepower, an enormous amount of horsepower. Why I think this is something you should consider in your shop is this type of design, it's made to withstand tremendous amounts of horsepower. And what this is going to do for you is really no different than a top fuel 20-car dragster. What I mean by that is this. When we recommend putting the sleeves in, we actually don't recommend using Loctite. We recommend press fit only. We usually recommend 1.5 to 2 thousandths press maximum. It goes as little as a 0.5 thousandths press. When the block is under load, as we all know, these blocks, if they're poorly tuned, you can drop a cylinder. In the top fuel market, as you guys know, while they're at the track, the blocks are hot. They drop a cylinder, crack the sleeve, they pull it out, get a new sleeve, drop it back in, and go. Same scenario here. The block becomes a reusable drag racing part. And so if your customer is is a budget racer and they're not going to put 1 or 2 blocks in their stable or in their truck when they go drag racing, they're going to come back to you over and over again should they have a failure. And the nice part about this sleeve design is because it's a sort of a integrated type of sleeve that's press fit, you can keep the block up, yank the sleeve out, get a sleeve from us, drop it back in, or hone it, and your customer's back on the road, back at the racetrack. Same situation for the open deck. Very simple design. Same thing. 0.5 thousand to 1 thousand press fit. No more than 2 thousandths maximum press. Again, sleeves do not need to be installed using CNC machinery. It just speeds the job. Most of you guys who are using like 20 rocker, for instance, a good machinist can easily cut this block, can easily drop the sleeve in. There should be no ambivalence, no hesitation to use this type of sleeve in one of your blocks. This is a Coyote. Many of you guys are this type of block. We see a lot of these, a lot of street racers, and a lot of drag racers are now using these blocks. They're inexpensive, but they can't withstand these are now getting on it at 1,800 horsepower, almost 2,000 horsepower Coyote block. But the sleeve block, these are very simple sleeve design, dry sleeve. But what I wanted to show you, kind of on the technical end of it, is trying to bring the camera in here real quick. A lot of these Coyote blocks, as you can see here,
Light's too bright.
too bright. Okay. I don't know if you guys could see that on the camera. I apologize if not. But you can see there's a little porosity hole. So you can go down a little lower here.
Oh, you can see it.
There we go. Very interesting when you bore the block out to put the sleeve in. Just a dry sleeve design. It's got a little flange top, as you can see here, and they're flatted. Occasionally on these aluminum blocks, you're going to get into some porosity right here. Something you need to look out for. I'll show you another hole down here. It's not common that you get porosity, but it does happen. A couple of different ways you can go about sleeving these blocks. You could run it to get a lot of across the holes. But as far as the 4.6, 5.4 modular block, this Coyote block, here's another K20 block back here. This block was sent back, as I mentioned earlier, this block was sent back to us. Used block, it's been bored in 90 millimeter, which is the maximum bore. Our customer wanted to debore the block, go back to 86 millimeter bore size, and what they've done is sent us back a block, heat the block up, push the sleeves out, and if I can get a shot of that block right there. We're going to come back in. We're going to press in some new sleeves for this customer. We do take a light skim off the deck of the block after we put the sleeves in, and he's back at the racetrack. I appreciate your patience, folks. I know this is an unusual type of webinar, and so if it's choppy on your guys' computer, I sincerely apologize. We're doing our best. We just thought this would be something different. That you guys would be interested in this type of a webinar. I hope you're enjoying it. I'd like to continue. What we're seeing now is something that's becoming popular, and maybe you guys are seeing this as well, are iron blocks that are getting sleeved. Let me show you two examples. We have right here is a Toyota 3S GTE cast iron block. More popular in Europe than it's going to be here in the United States. And here we have this is an old, early 90s BMW. Obviously, this is an inline cast iron block, 6-cylinder. And we have a couple of different sleeving methods that have been becoming quite popular these days. And I wonder if you guys are seeing it. On the BMWs, the bore spacings for the BMW blocks not very wide. And so when the engine builders are putting a lot of boost in those blocks, they're getting fracturing in the depths. So an idea that's been brought up by a number of engine builders out there is rather than sleeving the block when a fracture happens, they've been sleeving the block and downsizing. It's a great idea because what they're doing is they're increasing the wall thickness and having custom pistons produced so that they can put more boost in the block. Something you guys should consider if it comes in the door, you get that type of a request, deboring is what's been quite popular lately. So let's start with this BMW block. So as you can see, the bore spacing here, we're trying to keep it as thick as possible. That's 80 thousandths of cast iron. And typically in cast iron, when you get 80 thousandths, it's thick enough to withstand a sleeve that's being pressed into it. What we're doing is we're adding another 40 thousandths, another 60 thousandths per side with these flange sleeves, and we're deboring the block. So they're going from 85 millimeter down to 83 millimeter. And using basic, simple flange sleeves, flatted like you see in an aluminum block. And again, it's a real simple design, deboring the block and giving the block greater wall structure, thus allowing for more boost pressure and allowing for essentially saving the block and giving it more life is what it's doing. Great idea. On this Toyota 3S GTE block, it's kind of the opposite. So it's a cast iron block at about 500 horsepower. These blocks tend to crack, usually in this area back here. So what the request we've been getting is taking this block and not only sleeving it, but increasing the bore. So what we do, we produce a sleeve like this, maybe go in the block, and what we're doing is we're taking the standard bore, which is 86 millimeter, and you're able to take it all the way out to 89 millimeter using this type of design. Now, when we have these requests to do these type of sleeve jobs or produce these type of sleeves, there's always different ideas. There's another idea that was presented to us. The idea was to bore the deck and block away, make a thick wall flash top sleeve, as you can see there. Pretty interesting, pretty unique. So you can see come on down and kind of recreate the deck. And as I mentioned earlier, the reason they wanted to do this was to eliminate fracturing on the deck of the block. So keeping the bore either the same size, 86 millimeter, or deboring it down to 84 millimeter, throwing nitrous and turbo in these blocks at the same time and cutting the deck away. Now, this type of job for your machine shop, it's a lot of work. You may not want to do it, but these guys pay huge money, and it's something that I always suggest you put in your back pocket as something that you'd be willing to do. The only downside to that is you do need CNC machinery to put in that type of sleeve. You can see all the detail at the top of the sleeve. It does require that. So these two type of sleeving requests or demands not only over the last 18 months, but over the last 4 years, for us, it's been quite popular. And most popular has been the BMWs, like the cast iron N54 block BMWs, again, deboring 5-cylinder and some 6-cylinder blocks. So you can see here. Now, as I spoke a little earlier, fixing what you got, you guys are probably going to have various requests coming into the shop. Machine shops are fewer and fewer throughout the United States. If you've got a machine center, it should be a profit center for you. And so when a block walks in the door, rather than turning them away, you should consider the job first. These are a couple of different applications in the power sports industry. Typical, this is a Suzuki 450 ATV cylinder. Very easy job, and I'll show you how. No different than sleeving any aluminum block. Counterbore from the flange, press fit, which is 4/1000 on a single cylinder. Machine the cylinder out. These bore sizes is 98 millimeter, so it's 3 inches, 7/98, I believe, which I'm sure your machinery can handle. Heat the cylinder up, drop the sleeve in. Very easy job. A job like this retails for $320 all day long. It's a good job to consider. Same thing. What you have here is a 107 cubic inch Harley Davidson cylinder. Again, counter bore, boring the cylinder out. Very typical job for us, and for most machine shops like yourselves, you should be able to handle that. Just got to be able to set it up. This cylinder right here is the Can-Am X3. I would think that you guys have been getting requests to bore these cylinders, and the reason is these guys put huge horsepower. They run turbo on their Can-Ams, and they crack all the time. And the reason is they're about 40 to 60 miles running turbo. That's way too big for the motor. And when that happens, these cylinders just simply can't hold that type of power. So we have 3 different types of sleeves that we use for this. This you should be able to do in-house.
You need CNC. You need CNC.
You do need CNC on one application. So we do a straight wall sleeve. We do a small flange top sleeve. And what's been most popular lately has been this setup right here. This is our amphibious design. And the reason we're making the sleeve so stout, so thick and burly, is because they're putting so much turbo boost to these blocks, they need to have something that can withstand that type of boost. And so the only downside to using this sleeve design is it does require a CNC, which I'm going to show you in a moment. The reason is the number 3 hole, it's got a flat side, as you can see here. And so you need to come in and machine that area with a CNC flush. And, so something that that's unfortunate, but something that we're doing, and I think you really should consider. Another thing I think you should consider are 2-strokes. 2-strokes are the most popular motor rebuild in the United States today. A little bit more work, granted, but it's something where if you're willing to get the tooling and tool up for it, well worth your money. Same theory as far as sleeving. It's got a flange top, cut a counterbore, cut down through the aluminum plating, and the sleeve. We heat the sleeves up in an oven, and the sleeves drop down right into place. Very simple job if you do it with regularity. If it's something that you're just getting started in, give me a call, send me an email. I'll be happy to walk you through it. I talk to people every day who are getting into 2-stroke sleeving. A job like this, gets anywhere from $340 to $450. These cylinders, this particular cylinder is a Suzuki cylinder, $890 for that cylinder from Suzuki. These people want to rebuild these. They do not want to buy new. Not only that, you can't even buy a new right now because of the pandemic. So you got to fix what you got. We've been extremely busy with the 2-strokes, something you should consider. It is highly technical. You do have to get into it with die grinders. But once you've done it a few times, take my word for it, it gets easier and easier, and you can really make a lot of money out of it. Same thing with this block right here. This is a V6 OMC. It's a 2-stroke. This is from the late 80s right here. These blocks are no longer available for sale. Sets up just like a V6 automotive. It's got names. You can set up on your typical throttler if you need to. Kind of has a 60-degree design, like the old 409s. Only downside is, like I said, you do need to do some port matching when you put the sleeve in. It just takes time to learn how to do it. Once you've got it, good money in this. This block right here, you get $1,800 to sleeve that block. Well worth your investment if you're willing to step in. Last thing I want to show you. Again, I mentioned transmissions earlier in the quality control room. These transmission housings, as you can see here, they wear out. The bearing races wear out. And so what we do is we come in, machine the top of the block, machine the bearing race out, take a sleeve like you see here, and press it in for the bearing race, as you see here. Very, very easy job to do once you set up. Obviously, you need different tooling. As you can see, the bore sizes are smaller than your average V8, obviously. But it's a good money maker, and because this particular transmission is off of Suzuki, which cannot be purchased anywhere in the world these days, you have to fix it. And so, if you think outside the box, anything can be fixed if you put your mind to it. And that's why we want to kind of expand your horizons. Last thing before I get any questions from you guys, these are just the different sleeve designs that we have, just to give you an idea of what we do. This is the most popular sleeve we've ever made. This typical round, small block Chevy sleeve. 64 million blocks produced in the United States. We've had to sleeve a lot of these blocks, and these blocks are also getting harder and harder to find. So your typical straight wall sleeve. Here's a flange top sleeve, kind of like what I mentioned earlier. We're getting thinner and thinner now because the technology is getting so much better on the materials that we have made. This particular sleeve right here is 77,000 stick when it's done, and it pulls up just great. This is that amphibious design that I mentioned earlier. Again, although it looks intimidating from the surface, it's just a simple press fit down below. You don't even need to put a press fit on the flange if you don't want to, and slam that sleeve into place. That's called our amphibious Procross Pro Cool design. The ridges that you see here on the sleeve, in case you're wondering, these ridges are for cooling. Kind of a convection idea where the coolant is going to sit against the sleeve for a longer period of time. And in doing so, it'll cool the sleeve in the block. That's why you're going to see that there. And we make aluminum sleeves, believe it or not. A lot of these aluminum sleeves that we produce are for motors that engine builders have an idea. Remove the cast iron, press in an aluminum sleeve, and then put Nickel plating in it. Some high-end motors are made that way, which I'm sure you're familiar with. And a two-stroke aluminum sleeve, same situation. Finally, just to give you an idea on CNC machining, this block right here, this is an Audi 2.5 liter block. It's the RS3 block. Over the last 3 years, this has become, really last 2 years, this has become an extremely popular block for sleeve. The reason is, although the blocks are very expensive, as you probably are aware if you look into the Audi motors, these blocks are being used because it's somewhat of an affordable car, sort of the middle class, high end type of racing type of street motor. They're putting so much boost in these motors that the stock Audi still cannot be boosted very high. So we come in, machine the block out, put in either a dry sleeve or amphibious design. These type of blocks are very easy to machine on a CNC because we use a flat table, as you can see here. And on that flat table, we lock it down. All of the tooling has probing. We find the center line of the block, and then we come in, machine it. It's a very simple job to do. If you got the CNC machinery, not so simple on this particular block on an F20, but it can be done. Just need to take the time to do it. So essentially, that's us in a nutshell. Rob, I think I'm done as far as showing you what we got. I don't know if you have any questions for us out there.
Well, super, Dave. Excellent presentation. It was, it's kind of cool to see just what goes on, right every day and what you're doing there. Thanks again for the tour. Dave, when you were talking about that Coyote block, it kind of got just cut off just slightly when you were talking about the porosity. Could you, if you don't mind, could you just show us that again?
Absolutely. The way that these Coyote blocks are produced, it's a foam casting that's a breakaway material, and oftentimes on these type of castings that come, this one's made from I believe these are actually made for Fomico, which is I believe is in Europe. Anyway, on the breakaway foam casting, it gets porosity in the aluminum, and so what you see here is when you machine the block out to put the sleeve in, which there's a very thin wall sleeve in from Ford. You can kind of see the sleeve liner in here. It's a cast-in liner. They're only allowing for 10,000, 20,000 oversized max. So when you put a sleeve in, sometimes you'll find that you're going to break through into the casting and get some porosity. When that happens, the block can be sleeved. It can be sleeved. Loctite is recommended to seal that area up. So it's not a throwaway situation. Some guys will spot weld the porosity before they sleeve it, which is okay. But the welding can warp the block a bit. So if they're going to spot weld it before they sleeve it, essentially you're going to at least have to sleeve the whole bank if you're going to roll one of those.
Okay, no, excellent, Dave. I've got a question here for you. It's kind of got two parts, so it's a bit of a longer question, but they're asking, what are some of the tips or tricks you use in-house when you're re-sleeving two-strokes to ensure port alignment? You know, they're talking about, you know, could you share preheat temp and time, you know, and do you hone the aluminum before sleeving for tighter tolerance or interference? So it's kind of a long-winded question there, but hopefully you got it.
Okay, I do got that. So yes, all of the above. So the two-stroke sleeving is not done in this building, it's done in the building across the parking lot. That was one of the things I was able to show you. But I can give you a real good idea of what we do. The sleeve on the two-strokes, we do like to hone the aluminum before we put the sleeve in, and there's just two reasons why, but it will make sense to you, I'm sure. Number one, as I showed you earlier, all of our sleeves are centerless ground on the outside diameter. It's got about an 8 RA surface, very smooth on the surface. What we do is we come in with a roughing hone, a roughing stone, and we'll rough the aluminum out. It's essentially, you're going to plateau hone the aluminum. And the reason we do that is, with the centerless ground sleeve surface, the plateau hone aluminum, and that sleeve goes in, it's going to have such a nice press fit tolerance that the heat will transfer at a better rate. Now, it's not absolutely necessary that the aluminum's honed. By no means is it absolutely necessary. It's something we do as a added value to our sleeve. It is more work, granted, but it's an added value, and it's really a better running product. But it's by no means absolutely necessary. I want to stress that, okay? That being said, we simply heat the cylinders up in a basic oven. You could use your mom's oven at home if you need to, which some people do, actually. So it doesn't really matter. We usually heat these up to about 425 degrees, roughly about an hour and a half. We just put it in the oven. We don't chill the sleeves, although you can. The downside to chilling the sleeves, it builds up condensation when you pull it up out of a freezer or dry ice. And that condensation can make for a little bit of an obstacle getting the sleeve down in place. Once the sleeve goes down in the cylinder, you have approximately about 12 to 15 seconds to get the sleeve ports lined up. But what we do is, this is a bad example, but it's an example. Generally, you can go through the exhaust port, and most two-strokes have bridges on the sleeves in the exhaust ports or on the intake. What we do is we drop the sleeve into place in an approximate position, and you can see the bridge in the cylinder, I hope, and the bridge of the aluminum. And we use these very long needle nose pliers. We actually stick the pliers down in the bridge of the exhaust and grab the bridge of the sleeve and the bridge of the aluminum together, and it matches it basically perfectly. Pretty crude, but extremely effective. So that's what we do, Rob.
That's a great tip. Yeah, that is a really good tip, for sure. So this question is in regards to flange sleeves. They're asking, do you surface the blocks after installing flange sleeves? And is there a bit that you use that works best for the cross cutting so that the sleeve, so you stop getting that dragging, you know, from the aluminum to the sleeve?
I'll answer the last question first. No, there's just no way to use a bit that can run from aluminum to cast iron without getting some drag to it. It's just not possible. We do fly cut it, and yes, we cut every block unless otherwise requested by the customer. Generally, what we do it right here on the CNC machine, although we don't have a fly cutter to set up now, but I'll give you a little indication of what we do. So what we do is we'll install the sleeves and block. Generally, they're going to be about 5 thousandths proud to as little as 2 thousandths proud. We come in with the fly cutter and use a carbide cutting tool, your basic carbide flight cutter with our CNC machine. The basic flight cut tool right there, carbide tipped, as you can see. And what we'll do is we'll come in, and what we do is we adjust the feed rate when we cut the aluminum and the sleeve at the same time. And it takes a little bit of experience, but when you change the feed rate as you're going across the deck of the block, it eliminates some of the drag. Not always, but most of the time it's a pretty smooth finish. The only time we leave the sleeves proud is there are some drag racers that ask us to leave the sleeves 2 or 3 thousandths proud. So what we'll do is we'll cut the block first, only aluminum to size as far as the press fit. Come in with our flight cutter, flight cut the deck of the block. And we'll drop the sleeves in, usually 2 to 4 thousandths proud. Try to keep it around 2. And drop that sleeve, and we won't cut the tops of the sleeves. That's only for drag racing. Some street racers want that, and we refuse to do it for street racers because the gasket is very challenged when the sleeves are proud on most street motors. So that's what we do.
Okay. Yep. No, that's good. So Dave, a couple questions here in regards to interference fit. So the first question is, what is the recommended press on a typical straight wall sleeve, like in a cast iron engine, a small block Chevy as an example?
Typical press fit guideline has changed over the years. And the reason it's changed is materials have gotten better. And it used to be at one time 1,000 per inch for press fit. So if it was a 3-inch outer diameter, 3 to 4 inch outer diameter sleeve, it would be a 3 thousandths press fit. That's no longer the case. We recommend a 0.5 thousandth to 0.8 of a thousandth per inch press fit for a cast iron motor. And so therefore, if you're sleeving a popular model that you guys may or may not be seeing these days, is like the 5.9 Cummins, the 6.6 liter Duramax, 6.7 liter Cummins. Those will go in with just 1,500 press fit. On the straight wall sleeves, no more than 2 thousandths press fit on anything that's a 3-inch to 4-inch outer diameter. It's simply not needed. 2 thousandths maximum press fit.
Okay. All right, Dave. So in regards to, let's say, an old cast iron motorcycle cylinder, what's the recommended interference fit? And do you heat or cool and press fit? And do you use lube or not, is the question.
On old cast iron cylinders, we use 2 thousandths interference fit on any cast iron cylinder for a motorcycle or any single cylinder motor. It's always 2 thousandths cast iron. That has not changed for as long as I can remember. I've been doing this since 1984. That's exactly the press fit that we use, and we do not use lube to put the sleeve in. And the reason is very simple, as I mentioned earlier. You heat the cylinder up in an oven. Cast iron does take longer to reach its expansion, but the sleeve will drop right down in without lube. And not only that, we don't use lube in the automotive philosophy. We just simply drop it right down. By heating the block, and the sleeve will drop right down.
Okay. All right.
Oh,
so Dave,
let me mention one. If I could mention, I want to give an addendum to that answer. Real quick. On the cast iron, so this is an aluminum Harley Davidson, obviously. On an old cast iron Harley, we'll put the sleeves in, and we'll take a plate, put it over the top of the cylinder after the sleeve goes in, put it down on a plate below, and we'll actually put a hydraulic press and hold the sleeve down into place as the cylinder is cooling to make sure it stays properly in place. On those old cast iron cylinders, if you feel uncomfortable with press fit only, what you can do is get a stainless steel pin, which you can find anywhere, take a stainless steel pin, you drill it into the bottom of the cylinder and into the outer diameter of the sleeve, and then just grind the head of the sleeve away after you do it. If you feel you need to have a stop so that sleeve doesn't drop down, that's another way for keeping the sleeve in place on an old cast iron single cylinder motorcycle.
Okay, super. Let's see here. Got the question here for you. Do you make any CGI or compact graphite iron sleeves, like for example for the 2.7 Ford Ecotec?
We do make compacted graphite iron sleeves, but not for that motor. We have made some CGI sleeves for some real high dollar projects. And the reason is CGI material is not expensive in volume, but it is very expensive in small volumes. So it's a material that's sort of really priced out of the general rebuilding market.
Okay, all right. Dave, we're going to go back to like whether you use a retaining compound or not. So no lube, but do you recommend a Loctite or any other coating on the sleeve for installation?
Okay, so going back to motorcycle cylinders, all two-stroke cylinders, motorcycles, Harleys, single cylinders, we do not use any lube or any Loctite retention of any kind. On automotive blocks, on the other hand, it's optional. And we don't use Loctite to put the sleeves in. We don't. Some engine builders just have a hard time not using sleeve retainer in automotive blocks. And that's okay. That doesn't bother us at all. Here to show you a visual. So for instance, on this Honda block here, this is the bed of the water jacket. So the water literally is traveling around the sleeves. And that bothers some engine machine shops. They feel like they should put some Loctite at least under the seating area of the sleeve, which is here, as a bonding agent so the coolant will not travel down below the sleeve. It's not really intended to hold the sleeve in place. It's intended to keep water from leaking. So in that situation, that's okay. On the other hand, like on this Coyote block that was behind me here, where it had the porosity in the aluminum, absolutely you need to use sleeve retainer in that situation. Absolutely.
All right. Well, Dave, that kind of sums up all the questions that we've got. We're going to let everybody, especially yourself, get back to looking after things there and back to your day. Really appreciate the tour. I mean, this is stuff that to be able to allow us to come in and see you and what you do here, and have you show us just how we can, shops can do things a little bit different. Like you say, fix what you got. So really appreciate your time, and thanks again. And for those of you too, I mean, in our Engine Professional magazine, Dave has done some excellent articles. If you go into our archives in our magazines, he covers a lot of this stuff, especially some of the, how to sleeve these coated cylinders and that kind of thing. And so really good insight. Dave, we always appreciate your help. And thanks again.
I'm grateful for the opportunity. If anybody needs any help, please feel free to call me or email. I love to help people fix what they got. Thank you.
Yeah, thanks. And what we'll do is anybody that wants Dave's email or anything, just let us know in the questions box. We'll make sure he's easy to find online, LA Sleeve, and you can Dave will help you out. He's always helping us out. We call him on the tech line all the time. So, Dave, thanks again, and we'll get on with your day. Thank you again.
Thank you, guys. Bye-bye.
All right, so what I'm going to do now is I'm going to go back over to Amanda, and we'll just wind things up for everybody here.
And lastly, if you have any questions for us here at AERA, you can see our contact information is there. Rob and I have our email addresses listed, and the 815-526-7600 phone number will get you to the main line at AERA, where you can reach us or anyone else on staff. So once again, thank you, everybody. We truly do appreciate you taking time out of your busy week for us, and we hope you all have a great afternoon.